Hi everybody. Okay, so now we're going to talk about acid-base today. Probably one of your favorite topics. It's also one of the most difficult ones that students struggle with, and so in this case we've drawn it all out for you here. So look at acid-base. In order to under acid-base and all the different disease processes between metabolic acidosis and alkalosis, and respiratory acidosis and alkalosis, you have to understand the players first and what's happening in the body from a physiological standpoint. So the players are, you've got pH, which actually governs the hydrogen ions. And so when you're acidotic, you're at a 7.35. When you're alkalotic, you're at a 7.45. CO2, when you're acidotic, is actually opposite. It's on the higher end, which is 45, and when you're alkalotic, it's 35. They say when you actually retain CO2, you actually drop your hydrogen ions. Your CO2 goes up, and then you actually, the pH will go down. So you got pH and CO2 relationships here. So they usually, the one kind of governs the other depending on what's going up and what's going down. Your bicarb on an acidotic standpoint is 22 and then alkalotic is 26. Now, a couple of things to actually consider, okay? When you're actually acidotic, you have to really think, instead of memorizing, don't memorize zeros, because we said on day one, we don't do memorization. When you're acidotic, you have to think you actually have too much acid. So what do you have to really do? You have to think about, okay, when you have too much acid, the body really either needs to excrete the acid, or it really needs to retain base, something like bicarb, to actually buffer itself, depending on what pathology we have going on. That's really important. So you have to kind of think of, what disease process do you have? So if you think about the disease process and what's actually happening in the body, that will actually help you understand, what do you need to retain, what do you need to excrete. Now, a couple other things to understand is that you have players that regulate acid base. Primarily, you've got, buffers, but then you also have your kidneys and your respiratory system that actually govern the compensation. And so, for example, if it's a CO2 problem, usually your lungs is the issue. Now, if your lungs is the issue, you can't really, that particular disease area cannot compensate itself. So the kidneys would have to do the job, right? Kidneys usually regulate a lot of your bicarb and other buffer systems. And so if the kidney is the issue, then usually the lungs is usually the one to compensate. And so you have to remember, though, the lungs usually take, seconds to minutes, and your kidneys sometimes can take, minutes, hours to days. So it depends on what disease process we're talking about. So the first one I talk about, actually, metabolic acidosis. And it is good to actually tack that with some sort of disease process, something like a renal failure, a diabetic ketoacidosis, the diarrhea, something like that. If you think about the disease process, you have to understand, first of all, metabolic acidosis. And if you think about acidosis, you have to, students usually ask, well, how do you know what problem it is? Well, it's not respiratory, so it's not the lungs, it's usually the kidneys. When it's usually the kidneys, then it's usually when it's acidotic, you have to think about, first things first is you look at pH. Oh, hang on there. So for example, let's go there first. pH is usually the first determinant, right? So if you're acidotic, then your pH is low, somewhere like around below 7.35, right? And then, now what does that mean though? If you have a low pH, then you have too much hydrogen ions, which is what gives you like the acidosis, right? So, but it's a metabolic problem. So your bicarb should usually be, because it's a metabolic problem, you possibly have like a kidney issue. Sometimes there's your mixed issues in there, but then because it's metabolic and not respiratory, we can't look at the CO2 for right now. Because it's metabolic, you have to look at the bicarb. The bicarb should be aligned with the pH, which means that bicarb is also going to be low, usually below 22, because, think about, let's use something like, diarrhea. So if you've lost a lot of fluid, what is going on? You lost a lot of base, so what you have left is acid. That's why you have an acidosis. So now you either need to have to get rid of the acid in order to bring the pH up, or you need to somehow retain some base to kind of buffer out the acidosis. Now, because somehow we're talking about a metabolic issue that may be related to the kidneys or some sort of metabolic issue, and your bicarb is primarily governed by the kidney, your lungs would have to compensate. So you have to think about, okay, what do the lungs need to do in order to get rid of acid? Okay, so with your CO2, what happens is that the lungs would need to increase the respiratory rate because you have to blow off the CO2 in order to decrease CO2, okay, because to get rid of the acid. And by getting rid of the CO2, you actually will bump the pH back up. And so what do you think you will see if you think about it from a physiological standpoint is as you increase the respiratory rate, right? You're going to bring up the CO2. That means you're going to see an increase. The lungs will compensate by increasing the respiratory rate to bring down the CO2 and then bring back up the pH. So when it's fully returned back to normal between 7.35 and 7.45, then you have brought the pH back to normal and you've now actually fully compensated. Now, you're not going to have to know partial or full compensation. You just have to understand the physiological mechanism of how the body is trying to correct itself in order to return it back to homeostasis. That concludes basic acid-base and metabolic acidosis. Thank you.